Okay, good afternoon. Let's get started. So as you think about migrating to the cloud, one of the first words that often comes to your mind is security. Now, this week and next, you're going to hear about exciting technologies on things like encryption or DDoS prevention. But at the center of cloud security, there is a critical element named people. All the best security tools and technologies are only useful if you can take control of what a company owns, how resources are provisioned, and who has access to what. And that is our topic today. My name is Rae Wang. I'm a product manager at Google. You're also going to meet a number of other amazing speakers throughout our session. So cloud brings a lot of benefits, scale, availability, agility. We all love building on cloud, and that's why you're here. When you move to the cloud, it's not just about moving your VMs from one data center to another. It is also the opportunity to adopt the Agile DevOps culture and to transform into a cloud-based company. You want to unleash your developers and let them run fast with the scale of cloud. But to do that with a peace of mind, you also want to put in the guardrails so that speed does not risk security and compliance. As you move from on-premise to cloud, the one thing you definitely don't want to lose is control. So what are some of the common resource control needs on cloud? I want to share a few stories that we have heard from cloud admins. One cloud admin came to me and said, back when things were all on-premise, it was very easy for him to account for all the assets that his company owned. So when he had to build an inventory to do scans or audits, he was pretty sure he included everything. But on cloud, it's a bit of a different story because you have many developers, and one of them can just pull out a credit card to create a new account, a new project, and spin up a bunch of VMs on cloud without the admin knowing. So what did this admin do? Well, he ran a quarterly cloud amnesty day where his developers were asked to come clean with the newly created projects and accounts and grant him access so he could include them in his inventory. But even with that, he still wasn't really sure he got them all. Cloud gives us a lot of flexibility. You can choose from many different types of VMs, different VM images, many different services. But just like in real life, we know where more choices is not always better. In a company, often standardization is what's required to meet compliance needs or reduce security risks, or even to optimize test investment. So our challenge is how to standardize resource configurations on the ever more flexible public cloud. Another hot topic lately, you probably have heard, is data exfiltration. Right, in the last few years, there has been no shortage of news on companies accidentally leaking sensitive customer data. On one hand, cloud eliminates one of the key risks, which is leaking data via a physical device, because you simply cannot take a USB key and plug into the cloud. On the other hand, though, now how you access resource is through cloud API endpoints. And these are APIs that are publicly documented, and everybody can attempt to access them. And therefore, your main line of defense is now access policies. And therefore, the principle of least privilege is more important than ever. So next, we're going to look at how the GCP tools will help you to take control of your resources. So first, we're going to talk about IAM. IAM stands for Identity and Access Management. It allows you to define a policy that says who can do what on which resources. The can do what part is defined by an IAM role, which is a group of permissions. To do a meaningful job, for example, if you want to let somebody manage your GC resources, it takes more than just a single command, right? They need to be able to create and delete and start and stop and do a bunch of things to the VMs. So we group them together as an IAM role. Now, in the example here, you can see we're granting the compute instance admin role to a number of users on a project. And that allows these users to be able to go in and manage all the GC instances in that project. So we first launched IAM last year at GCP Next. And since then, we have shipped many more predefined roles. We're now at over 60 roles across most of our major services. By using these roles, instead of the primitive owner, editor, and viewers, you can grant more granular permissions. For example, if you want to give your developers permissions to, say, look at logs so they can do debugging, but you don't really want them to poke around the PII data in your GCS buckets, You can grant them a log viewer role on a project so that the only thing they can use in a project is logs. Now, you can grant these roles on projects, on organization, which we're going to talk about a little later. In some cases, you can also grant them on the individual resources, for example, on GCS buckets or BigQuery datasets. So the top question we got after last year's launch, after our, last year was 20-something predefined roles, was, can I create my own custom roles? Even at 60 roles, we still have customers who come to us and go, I just need to tweak that a little bit. Can I have my own custom roles? So today we're happy to announce that IAM Custom Roles has launched to a public alpha, which means you can go to the doc site and sign up to be whitelisted. So you can create custom roles by either grouping together a set of permissions or by modifying one or more of the existing roles. For example, if in your company you want to let your developers manage GCE instances, but you don't want them to open up external IPs, so you can create a more restrictive role by taking the instance admin role and removing the permission to create external IP. Or maybe you have a service account whose sole job is to attach PDs to VMs. Then you can create a very small role with just that permission for your service account. Custom roles can be created at a project level to be used by application or team, or they can also be created on the organization level, and then all the developers and all the projects in your company can access the same roles. So since the I in IAM stands for identity, I want to mention it here, even though we're not going to go into details, because it's covered by a couple of other sessions. Yesterday, there was a session on Google's Identity as a Service that talks about how to manage users and groups and federation. If you missed it, don't worry, the recording will be on YouTube in a few days. And tomorrow, there's going to be a session on the best practice of managing IAM for GCE, during which we're going to go into depth about how to secure your service accounts. Okay, so we talked about the permissions. Well, these permissions are assigned on resources, so it's important to talk about how resources are defined and grouped on GCP. What you're looking at here is a resource hierarchy, because we know that they're not just a flat list of VMs and GCS buckets. We don't want to manage them one by one, so we want to group them together. Now, if you're already a GCP customer, you're probably familiar with the concept of a project, which is this yellow layer in the tree. A project is a basic resource container for GCP, and it's also a policy unit. On the top of the tree, the blue layer, that's the organization node, which we also launched last year. And this is your company's root node for managing all your GCP resources. Now, since then, we have added the red layers in the middle called folders, because many of you came to us and said, well, my company is large. We have multiple independent divisions, branches, departments. We want to manage them differently. So we have added these layers so you can model your departments, your organizations within organizations. Now, IAM policies are inherited from top down in this resource hierarchy. So if you have the admin permission on the organization node, that gives you admin permission into all the folders, projects, and resources in your organization. At any of the nodes, the permission that you get on a resource is a combination of the permissions that are directly assigned to the resource, as well as all the inherited permissions from its ancestors. The reason we do that is so that it's not possible for a resource owner to lock out a central admin who's granted permissions on a high level. So let's look at organization node a little more. Organization node, as we said, is the root node of your GCP resources. So all of your other projects, folders, resources can belong to your organization node. One recent addition is the billing account. So now billing accounts can also be moved underneath your organization node and get the same inherited IAM permissions. So if you have multiple billing accounts, all you need to do is to assign your billing admin team the billing admin role once on the organization level, and that gives them access to all the billing accounts underneath your organization. The organization node is linked to your G Suite domain. So that allows us to enforce the ownership policy, which says if any identity in your company goes and creates a new project, it will automatically belong to your organization node. You don't have to do any extra work, it will just be enforced. So it prevents shadow projects, rogue admins. You can't have projects created without you knowing and having visibility. A number of organization-wide management tasks have also become easier with the org node. For example, as an admin, you can control who in your company is or is not allowed to create resources by carefully assigning the project creator role. You can also now finally build inventory. You remember the beginning of the talk, we talked about the admin not knowing the inventory. Now you can build it by programmatically enumerating through the projects and the folders, projects, and resources underneath the organization node. Another common practice is to have a service account with org-level permission to do company-wide config monitoring and enforcement. And that is, in fact, what our Google's own security team does. Folders, as we said, are organizations within organizations. So all of these management benefits can also be done at a folder level for your department admins. Okay, one new thing we want to announce that we have recently added to the organization node is the organization policy. So we talked about flexibility and the need to standardize configurations. Well, the organization policy allows you to do exactly that. You can define the org policy on the organization node. It will get inherited into other projects and resources underneath. You can also make exceptions on a per-project basis, but even the exceptions are controlled by the org-level policy admin so that project owners can't just create a loophole for themselves. Now, what's different from the IAM policy is that the IAM policy distinguishes different users with different permissions, whereas the org policies are assigned on resources, and they apply to all the users who access the resource, including our project owners. So let's look at one of the policies in a little more details. So this is the allowed services policy. What this policy allows you to do is, you remember how when inside a project, you can go and enable many different APIs representing different services you can use in a project. This policy allows the central admin to say, here are the only allowed services that can be enabled in my company's projects. In this example here, the admin says, I'm only allowing 2 services to be used in our projects. Now you can do this either for compliance reasons, or you can do this for cost control reasons. So this policy then gets inherited into other projects. And then when a developer attempts to enable enable a service that's not allowed by the policy, they will get a clear error message indicating that this is prevented by the org admin. Now then you have a couple of projects where you need to make exceptions. So project A is a more sensitive critical application that needs to have a more restrictive policy. So the admin sets the exception to say, I'm going to replace the inherited policy by a new policy that's more restrictive, that only allows a single service. Now, project B is maybe a test environment, right, where you test out new services before you release them to your developers. So in project B, the exception that's set says, let's inherit the parent's policy, but also augment it by adding 2 other services, so project B can use up to 4 services now. Okay, so we went through, you saw many different IAM roles, different types of policies. I know you also have a lot of users, a lot of resources. And we all know managing those manually quickly becomes unscalable. We wanted to go home for a weekend and have dinner with our family. So automation and templatization is going to be very key to your management experience. We all know that the way to deploy an application or deploy a VM is not by manually clicking buttons. You want to templatize them to avoid unique snowflakes. And now the same can be done with project provisioning. In company, it's typical that there are a set of centrally defined configurations for projects, such as how they should be named, which APIs are enabled, which billing account to use, the default IAM networking policies. You want to set these configurations once centrally, and then developers, as they spin up new projects, don't have to go and think about it every single time. So now all the APIs for these key steps are available in the public, so you can write your program, your script to program against these APIs. You can also wrap up your configuration into a template and have deployment manager drive the automation for you. So now that you have your resources deployed, you still want to know what's going on in production. You don't want to fly blind. And you can leverage the audit logs to keep an eye on what's going on in the production system. So the audit logs now capture, the admin logs now capture all the policy changes, including IAM, networking, and so on. So there are a couple of things you can do with that. One is you can use Stackdriver log-based metric to, for example, set up a metric on the event org.setIAM policy. And then you can set up an alert in Stackdriver on that metric so that every time the org-level IAM policy is changed, you get notified, you get alerted for that. You can also export your audit logs into PubSub, and then use PubSub to trigger Cloud Functions. Cloud Functions is a product that allows you to define if this, then that type of rules. So if you want to prevent an identity outside of a company from being added to your company's IAM policies, you can define a rule to look for that pattern and then trigger the action to revert the policy change. We also have data access logs, which capture all the data access records. So every time you use access data, it will be captured. You can export the data access logs into BigQuery. And then using BigQuery, you can answer questions such as, when was the last time person X accessed resource Y? And this allows you to do two things. One is if there are unexpected access pattern, a user shouldn't have access to something, you can catch that, and then you can figure out why, where you need to fix their policy. Or alternatively, you can find out that certain policies are just not getting exercised. Person X could access resource Y, but they haven't done that for years, so it's time to retire that policy. OK, so we just went through the building blocks. You heard about the different APIs and tools and policies. Now let's put them together end-to-end and do a few policy design exercises for a few companies. You can see that by using the same tools, the same policies, configured differently, you can build resource management systems for companies with very different priorities and cultures. So first, we're going to talk about a traditional enterprise. A traditional enterprise likely has existed and succeeded in the industry for quite a while, so they have built up a sophisticated organization structure because of growth and because of mergers and acquisitions. They tend to care a lot about security, compliance, and separation of duty. They also tend to have a lot of existing tools and internal systems and even on-premise deployments that the cloud deployment needs to be able to fit in. So this is an example design for traditional enterprise. The identities can be centrally managed in their existing out-app services. And then these identities can be federated into Google via the identity sync. An organization node is provisioned on top, linked with the identity domain, so that you can have full visibility and control of your company's resources. Now, for a traditional enterprise, procurement decisions are often made at organization level. And the creation and changing of resources are done through kind of centrally by existing tools, perhaps through a service account. And therefore, developers don't really need permissions to go and create or change resources. They can request those to be done through an existing workflow. Folders are created, as we talked about, to model maybe your different international branches or different independent groups. They can be used to grant these different divisions different policies, as well as a way to do cost aggregation. Let's see. So one other practice that we have commonly seen is to pre-create groups for all the major IAM roles that you want to use at your project and folder level. And then post the initial provisioning, you can even drive all of your IAM policy changes throughout app system. So that was the traditional enterprise. Now let's go to the other side, which is in a very agile DevOps cloud-bound company. So in the agile DevOps team, the priority is often to optimize for team autonomy and velocity. You want to let your developers run fast, and your developers are trusted to make their own decisions on what tools to use, how to deploy and monitor the apps. But like we said, the admins still want to set in some guardrails so that the developers are still operating within the bounds of security and compliance. So here, underneath the organization node, you can provision folders for different teams and departments. What's different here is that these teams and departments fully own all the resources and how to deploy and manage them underneath their folders. Of course, there are some centrally shared infrastructure resources that don't belong to these individual teams, such as your cross-project networks or your Stackdriver accounts. So those can be curated in shared infrastructure projects or folders and only managed by your central networking or security teams. Here, since the developers get to do their own things and make their own choices, the admin can set the organization-wide org policies to set those guardrails so that only the blessed config options are available to the developers when they choose to deploy their applications. Now, the service account here that has org-wide permission takes a slightly less active role and no longer is in the critical path to deploy applications for developers, but instead it does org-wide aggregation and monitoring. Okay, so a third type of company that we commonly see is an education or training company. In such an organization, the training owner usually owns the billing account and all the cost that's associated with running the labs. Isolation between both the users and between the users and lab owners is very critical. The entire provisioning process needs to be fully automated end-to-end so it can be fast and scalable. So in this case, the lab owner can use a G Suite domain to host the identities of the lab users and use the org node and folders to host the resources used for the labs. For every new session, a temporary user ID can be created and approached correspondingly. And so the user's activities are fully contained within the project, and that creates isolation. And at the end of the session, it's very easy to just wipe out both the project and the user. One thing that a lot of lab owners are very concerned about is abuse, because when you are paying for those VMs, you certainly do not want people to be using them to do Bitcoin mining. So there are a few ways to help you to address the abuse concern. One is that projects come with default quotas. So unless you raise them, the defaults are set low enough to prevent a user from spinning up a large amount of resources to abuse their resources. You can also set organization policy, as we talk about the allow services policy, to restrict every lab to only be able to enable the necessary services for the labs. And then the identity domain allows the admin to have the last say here, because only the admins, not the users, can control the identities. So if the admin comes in and disables or deletes an identity, that immediately removes all the access that the user can have to these resources. And since the user can't come back and change it back, there won't be any race condition. The admin has the last say. So how many of you tried early on the week tried the security boot camps? Raise of hand. There are a few. So the security boot camps were actually built on this architecture. They were built by this company called Quick Labs, who is a training company and also a recent Google acquisition. So if you need to provide courses and labs in the future on GCP, you can either use Quick Labs as the platform or use this reference architecture. So we have just seen that using these same tools and policies configured differently, you can cater to 3 very different companies with different priorities and culture. And next, let's invite on stage my colleague Rae Colline to show you the demos.
All right. Thank you, Rae. I'm actually Rae Colline, a software engineer who's worked a lot on the organizations and folders products. In this demo, we are going to show how a hypothetical G2X corporation can use GCP to lower their costs and gain a competitive advantage in the candy bar industry. Let's explore how they can use the flexibility of this hierarchy to organize and gain control over their GCP resources. To produce the 2 different bars in every package, the G2X corporation has organized themselves into 2 divisions, left G2X and right G2X. These 2 divisions have very different corporate cultures and requirements. We will show you how you can use the GCP resource hierarchy, IAM policies, G Suite groups, service accounts, to support a configuration that uses policy scanners, audit logging, organization policies, and project templating to gain control over their resources. Now here is the Manage Resources page within the Cloud Console, where we can get an overview of the G2X GCP hierarchy. Now note, I will only be showing the resource hierarchy and their associated IAM policies that enable all of these configurations. Now looking at the top level folder, we see that there's an organization node and 2 folders. The first folder is for their IT team, and the second folder is for all of the different product teams. Now within the IT folder, we have 4 projects. One is a service account container for centralization of service account management. The second is an IT security scanner, where you can run the open source IAM policy scanner and some homegrown tools to ensure that the configuration of all the resources is correct. The third is an IT project templating project where all of the templates that ensure standard configurations are contained and where they get provisioned. And fourth is an XPN host network where all of G2X's networks live. Now, let's look at left G2X. Now there, central control is a core requirement to their business. They value standardization to lower costs, increase security and reliability, and to minimize the variations that need to be evaluated against their compliance regimes. In fact, left G-Twix finds themselves under PCI compliance. We will now show you their IAM policies folders and project setup. So first, we can see on their divisional folder that in the viewer role, there's the IT security scanner service account. And this is inherited from the org node. And this gives the ability for the security scanner to see every resource within the left G-Twix division. Secondly, we'll see that both for folder creator and project creator, the G-Twix provisioning system is the only one allowed to create folders and projects. And this guarantees that they use the standard setups that are prescribed by their requirements. So when we go into the folder, we'll see that they have 3 different projects. They have a dev, test, and prod project. Now the dev and test projects are set up very similarly. For the dev projects, we will see that the owner is the provisioner. And what this means is they used a templating system to set up this project to keep it standard. And they've given the G Suite group that represents their dev team the ability to have editor rights. Now, editor is a fairly broad role, and this is generally okay because their dev and test projects do not have customer or revenue data. Now, when we look at the production project, we will see that the owner is still the provisioning robot, and in fact, the dev and test prod projects have the identical setup because they were provisioned with the same template. But the editor access is only given to the current SRE on call. And we can imagine that on-premise, G-Twix has an Active Directory system that's hooked up with some group workflows. And they use calendar-based and time-of-day-based rules for putting people into groups. And then those groups are then synced using the identity sync features of G Suite to push them into G Suite so we can use them here. And so this means that only the current on-call is actually given access to this group. Secondly, we'll see a few limited curated roles that we give to people with prod access, which is another similar one of these managed groups. And we employ the principle of least privilege, which is required by PCI compliance. So let's review left G-Twix. 1, we prevent users from creating projects and other resources to avoid snowflake setups and loss of control. 2, we employ the principle of least privilege required by PCI and other compliance regimes. 3, we use group memberships on IAM policies and use workflow and group integrations to control memberships. And 4, we use different policies for production and dev projects. So let's talk about right G-Twix. Now, they have a completely different set of requirements for their use of GCP. They wish to run fast and loose to give room for innovation. They value independence and the ability for teams to choose the best solutions to fit their needs. Fortunately, for right G-Twix, they're not under any compliance regimes. However, the G-Twix IT department wants to ensure that they have sufficient guardrails around their usage to keep things safe. I will now show you the right G-Twix organization. So in their divisional folder, we will see that, again, the IT security scanner, inherited through the org node, has viewer access, and therefore it can look at all of the configurations and resources across their division. 2, that in the folder creator and project creator roles, their entire team group is able to create projects and folders. 3, we let them have folder viewer access so they can see their colleagues' folders. Now going in here, we will see that there's an experimental project. And this experimental project was created by one of their engineers, Jenna Wu, who's working on their next generation system. And we'll note that she has owner on this project. And this lets her invite her colleagues as she sees fit. We'll also notice when we look at their dev project that the owner is not the provisioner robot, but instead is their dev team. Because at Write G-Twix, they allow for homegrown scripts and for one-off setups, again, to fit their needs. So let's review Write G-Twix. 1, they allow anyone in their org to create folders and projects. 2, even with the looser configuration, they still lock down their production product to SRE and those who need to know. 3, they encourage innovation by allowing experimental projects. And 4, the G-Twix IT team uses the IT security scanner to ensure that Write G-Twix does not have any large vulnerabilities or other types of security issues. So overall, we have seen how G-Twix IT has been able to use the organization, folders, IAM, and groups, and service accounts to configure their resources to fit their unique needs. Now, if you're curious about project templating, service accounts, organization policies, group management, and policy scanning, please see us at the PM Sandbox afterwards. Now, it's great that we reviewed this hypothetical organization, but now we bring on stage Lukas Karlsson from the Broad Institute to give a real-world example of how they organize their GCP resource hierarchy and to achieve their organization's needs. Thank you, everyone.
I'm Lukas Karlsson from the Broad Institute. I'm the cloud architect and developer advocate at the Broad. The Broad is a nonprofit genomics and biomedical research center located in Cambridge, Massachusetts. I started there in 2003, just after they completed the Human Genome Project. And then at the time, we were called the Whitehead Institute Center for Genome Research. The Broad itself was founded in 2004. And you may have heard of us, if you hadn't heard of the Human Genome Project, you may have heard of us more recently in regards to our patent for the CRISPR-Cas9 system for editing genes. The Broad gets its funding from a variety of sources. For example, philanthropic donations, federal government grants from the National Institutes of Health and the National Cancer Institutes, collaborations and partnerships with industry, and technology licensing opportunities. Each of these funding sources for us translates internally to something called a cost object. We use these cost objects to pay for the services, materials, and staff that support the research. Cost objects for us have very specific rules about how they can be used, so before you can use your cost object to pay for GCP services, you need to go through a complicated approval process. You have to work with your grants administrator to determine if the grant can support the volume of spend that you're looking to do, and to understand how long the grant is available, and whether it's even allowed to be used for cloud computing services. Once you've received approval for using your cost object in the cloud, we will create a billing account for you. Broad is set up similar to a GCP reseller in that we have one master billing account, and we receive a monthly invoice from Google for that. And we have dozens and dozens of things called sub-accounts, which sit underneath the master billing account. Each of these sub-accounts for us corresponds to one of our internal cost objects, and we have about 75 of them today. We're also a G Suite customer and have been since 2010. Over the years, we've actually accumulated more than one G Suite domain, so we actually have multiple organization resource nodes as well. We use the IAM folders functionality to organize our folders and to grant permissions to the projects. We map the folder structure very similar to how we map the actual organization. So in the example you see here, the IT department has two organizations beneath it, engagement and operations, each of which have a folder, and they collect all of their projects in that folder. In general, the person who's the leader of that organization is the folder administrator on that folder, and they can control whether projects get put into the folder or whether other folders can be created underneath that folder. We apply a number of organization policies at our org node at the top level. For example, we're rather open about project creation, so everyone in the Institute is able to create projects, but we're very strict about how money gets spent. So no one is allowed to enable billing on projects except for specific people who are billing account administrators. The billing accounts that we have, all 75 of them, are in our org node as well. So we're able to apply the billing account creator and billing account administrator and a few other positions at the org level so that someone in our procurement department can oversee all of the billing accounts that exist and can end them when a grant has ended. We also have some folks in IT who oversee administration of all of the projects, and so they have owner-level access. And then, as has been described a few times, we have a service account that can read everything, and that allows us to do automation and security scans and so forth. We use project labels to some extent. Initially, we were using them to track which cost object, but when we moved to the billing account model, we've stopped doing that. We use them to track which environment a project is associated with, and now that resource labels are available, we've started using those on some of our resources to track like how much a particular workflow might cost. So provisioning projects in this model can be quite time-consuming. I have one example that Rae and I have discussed repeatedly a year or two ago. I had to create 50 projects for a workshop where each person would have their own project. And so to do so, I opened 50 browser tabs, and I clicked Create Project 50 times. And then I proceeded to follow all the steps that I have here on the screen. So for each one, I had to enable billing to the appropriate billing account. For each one, I had to enable a handful of API services in the API console, some of which you click and wait for the service to enable before you can click and enable the next one. We had to set about half a dozen IAM policies on each project so that the right users could administer the project and the right service accounts could interact with the project. And again, we had project labels. We had to enable, these projects were all compute projects, so we had to enable the compute usage export for each of them, as well as now a new thing we do today is set the default compute region and zone. So this is a very painful process, and this is actually something, I was doing this manually in advance of the workshop, but the application that we built on Google Cloud called firecloud.org, it has to do this as part of the service. So there's no way that the application can expect a person to go perform all these tasks. So we've automated this. Initially, we automated it in Python using a simple script. And then now the same functionality is built into our Java application as part of our cloud service. So real quick, I'm just going to I'm going to talk about the Python tool that I've made to do this. It's open source. It's available in GitHub. My username is LUKWAM, and I think it might be the only thing there currently. It currently uses the application default credentials, so it's very easy to just run it right after you do the git clone. You don't really need to do anything special, especially if you are on Google Cloud Shell and you already have all of the resources installed. And I currently am using a YAML file to configure templates. So for any type of project I want to create, I can create a YAML file that has all of the desirable settings for that project. Here's an example of how it would run. You basically run the command and then specify which template you would like to use, and you have a folder where you store all your templates. In an upcoming version, it will also look for templates in a GCS bucket. If you wish, you can also avoid using the template, or you can override settings in your template with the command line options. So if your template puts all your projects in a particular folder, but for this one, you want this project to be in a different folder, you can specify that at the command line. And real quick, I'm just going to go through what the various options are that are currently supported. So upon project creation, you can either automatically set the parent to your org node or to one of your folder nodes using the Cloud Resource Manager API. It enables a billing account to the specified billing account. As I said, we have 75 of them, so depending on what you're creating, you have to know which billing account to put it in. It sets whatever desirable IAM policies on the project using the Resource Manager API. It enables each API service, like compute and storage or whatever is needed for your particular situation using the Service Management API. It can put project labels on the project, which we'll use, for example, if we have 3 projects where one is dev and one is test and one is production, you can put an environment label on there to tell which is which. It will create service accounts using the IAM API, and it can also create keys and download those keys. And it can set some default compute settings. If you specify a compute usage bucket that doesn't exist, it will create the bucket in GCS first, and then set that as your compute usage bucket. If it does exist, then it won't bother. And here is an example of it running. And then real quick, I'm actually going to attempt to do this live for everybody. So if we could switch to the computer. Here is the Git repo that I mentioned. Here is a very simple template, which literally just sets the appropriate billing account. It sets my super admin account as the owner, and it sets the Google group DevOps at Broad as an editor. It puts a label on it, which is the former way we used to track cost objects across projects. And it sets a folder, which is the DevOps folder within my organization. So real quick, I will just run an example of this. And the first thing it does is print out the template describing what it is going to do, and that shows which billing account, which folder, and which policy and labels are going to be set. And then it has created the project, it has set the IAM policy, enabled billing, and created labels. And there's a link right here that if I want to load up the project in my browser just to make sure it did the right thing, I can do that. Boom, project created. One other example I will show just so everyone can feel the pain of the provisioning process for FireCloud. This is the template for FireCloud. So we had about 15 different APIs we had to enable. We had 9 different IAM bindings that we had to add in there. We had to create 3 different service accounts and so forth. So now all of this can be done with a single command line where I specify the names of all 50 projects and the template that I want to use, and then I walk away and it does it automatically. And that's the end of my demo. Back to Rae.
Okay, can we switch back to slides, please? Okay, thank you, Lukas, for telling us Broad's story and also for sharing your project provisioning tool. We know that admins and developers love to create and share tools and want to leverage the open source ecosystem. So now let's look at some of the open source tools you can use to manage GCP policies. Google has a legendary security team, and they have created an internal tool set for managing Google's own GCP usage. Now we want to share the same learning and same capabilities with our GCP customers. So we're happy to announce that we have just launched the Forseti security toolset to GitHub. Forseti is the god of justice and reconciliation, and the Forseti toolset can help you to watch over your GCP policies. In this first launch, we have included an inventory tool that builds, creates and stores an inventory for your organization, starting from your projects and the IAM policies. The policy scanner detects policy violation between ideal and actual states, and the enforcer will centrally manage and apply changes to your policies starting from your GCP firewall rules. Now, you can use these tools as building blocks to build your automation systems, both for GCP and for on-premise. And we also want to invite all of you to contribute and share your tools with us. And one of our first contributors is Spotify. Spotify has a very similar problem as the Google admin team, which is they have many projects, and they also have security policies that they want to make sure that developers follow. So they're very excited to contribute and to help us to grow the community and accelerate the development of the tools that we can all use. So we also have a survey here that you can use to tell us what additional open source tools you want us to add to Forseti. Okay, so we're going to build brand new tools to help you to do your job on GCP. We also want to make sure that if you have tools that you already know and love, you can also use them on GCP. And one of these tools is the Security Monkey. The Security Monkey was built and released by Netflix in 2014. It does continuous scanning and analysis of your policy changes and alerts you on risky patterns. We recently added integration for IAM, GCS, and networking so that now you can leverage the power of SecurityMonkey for your GCP resources as well. Well, a few minutes ago, we talked about how to use either the APIs or deployment managers to provision your projects. And that works great on GCP. But I know that some of you also have to manage resources not only on a single platform, but across multiple clouds or between clouds and on-prem. And you want to have a single tool that can work seamlessly across these different platforms. And for that reason, we recently added the provisioning capability into Terraform, which is a popular multi-cloud config management system. So now I want to welcome on stage Seth Vargo from HashiCorp to show us how to provision a GCP application end-to-end using Terraform.
Great. Great. Thank you, Rae. Hi, everyone. He was first. All right. Let's talk about Terraform. How many people here have heard of Terraform before? Awesome. So Terraform is a completely free and open source tool. You can go download it right now. It lives on GitHub. Built by the folks over at HashiCorp. That's where I work. And we're here today. If you want to come say hi or you want to ask any questions, stop over by Charlie 6. We'll be there all day and tomorrow. But Terraform is designed, like Rae said, for those multi-cloud, hybrid cloud situations. So it's very rare today to have all of your resources in one cloud, especially if you're a company that's been around the block for a while. You probably have some on-premise infrastructure. You probably have some stuff in those other cloud providers. You probably have some stuff in Google. And you really need a way to describe all of those infrastructure resources. What Terraform does is it provides a single configuration file format, a text file, that allows you to describe all of those resources across multiple clouds and other things like top-level DNS. Maybe you're using a third-party DNS provider or DDoS mitigation, and you need to codify all of that into a file. And when we put that into a file, what we get is theft. We get to steal everything that application developers have had for years and apply it to infrastructure. Because application engineers have these great things. They have CI, they have CD, they have linting, they have testing, that when you're just running shell commands, you don't get that same level of automation, that same level of testing. So Terraform enables things like testing, automation, project stamping. You get VCS and GitHub integration. You can keep track of history of all of your resources across the infrastructure. And because Terraform has a common state format, you can build APIs and automation around that. So what are some use cases here? Well, many people run in multiple environments. You have dev, you have prod, you have QA, you have staging. And how many people here have a long-running QA environment that costs them thousands of dollars a month? Yeah. And how many people here never use that environment? It's just sitting there wasting resources. Or you have the opposite problem. Maybe you have this one dedicated QA environment, but all your developers are queued up, waiting for changes, waiting to get approval, and they're sitting in a large queue, and you're wasting resources. Terraform can actually solve both of these problems. Because Terraform builds a graph of your resources in these configuration formats, it can quickly stamp out entire environments, sometimes in less than 5 minutes. So instead of having this long-running QA environment that's costing you thousands of dollars a month, just spin one up. In the amount of time it takes your developer to walk to the water cooler and back, they could have a full development environment ready to go, send the URL off to the QA team stamps it, you destroy the project, maybe it costs you $25. And this can all be done in parallel. If you have multiple QA engineers, you can have multiple people approving deployments, and they can go out in parallel. So it really ties into those DevOps and Agile practices. The same thing can be applied for things like CI and project stamping. Maybe you're an IT team, and you need to give different organizations exactly the same thing over and over and over again. But it's multi-cloud. How would you do that? Well, with Terraform, you define the configurations, you change 1 or 2 attributes, and you can very quickly stamp out different projects for different teams in the organization. And lastly, continuous integration. Everyone loves Jenkins. It's one of the most popular CI tools. But we tend to have these really long-running CI environments, and they gradually become snowflakes over time, where we have different tools installed and different plugins and widgets. And we run them overnight, even though we don't have any CI running overnight. So we're paying for them to live on forever. With Terraform, you can codify those. You can quickly scale them up, quickly scale them down, and turn them off overnight. So you're not paying for those unused resources. So I want to quickly go through an example here for project templating. And the best way to think about this is some of the previous examples we saw where you have training environments or isolated projects that you want to create. This is the workflow you saw before. If you were doing this in the UI or through the API, you'd have to create a project. You'd have to enable billing on that object, then enable the APIs, optionally create service accounts, set IAM policies. That same workflow that Lukas talked about that involves clicking buttons, and it's relatively painful to do manually. Thankfully, Google has a number of APIs, and Terraform consumes those APIs. So this is an example Terraform configuration. And just like whenever you need to talk to Google's API with curl or with the command line, you have to give it your credentials. It can consume the local G-Cloud credentials, or you can provide them via an account file. So here, we're just telling Terraform how to talk to Google. Next, we have to define what's called a project. This can be created multiple times. So this is creating a project that's named Terraform Demo 12345 I'm attaching it to a billing account, and then I'm putting it inside my organization, and I'm just giving it the human-friendly label of demo. And I could create multiple projects. I could put this piece of code multiple times on the same slide to create multiple projects. Or I could use a count attribute to create 10 projects all at once. Within that project, I then have to enable services. By default, if you haven't configured the org node, when you create a project, it doesn't have any APIs enabled. So we can use the Google Project resource, or Google Project Services resource to enable services on that project. The project is the name of the project I just created. And then here I'm enabling IAM and the Cloud Resource Manager APIs. Then we can optionally create a service account. So that service account here is going to be created inside that project. I'm giving it a human-friendly name of demo service account, and I'm attaching it to my account. This service account has no permission, though. So what we have to do is we have to generate an IAM policy. Here I'm using Terraform's data source to generate an IAM policy that grants the editor role to my service account, the service account I just created, and it's granting me owner role over the project, so I'll be able to be an owner. And you can specify this binding and these roles multiple times to create different memberships. And you can get as fine-grained as you like, and we saw a lot of examples earlier of fine-grained IAM permissions. And then lastly, we have to upload that policy to Google Cloud. So we create an IAM policy, we assign it to our project, and we give it that policy data. So now we've templatized and programmatically created a project with a service account with the APIs we needed, all in a single configuration format. And this could be across multiple clouds. What you're seeing here with this $curly brace syntax is Terraform's interpolation syntax. Terraform builds a graph under the hood by using this interpolation syntax. So it'll parallelize these operations and create these resources as fast as possible. So if you're creating 10 projects and your quota allows for you to have 10 projects created simultaneously, Terraform will do that for you. If you have a big, huge quota, because you're someone like the Broad Institute, where you're creating lots and lots of projects, you can create all of those in parallel. So provisioning times could be as low as 5 to 10 minutes for some of these resources. You can also manage these changes over time. So if this project changes, maybe you want to update the name of it, you want to change the service account or the IAM policy, you change it in the config, you check it into source control, you get the pull request, approval workflow, then you apply those changes to production, and Terraform handles the diff for you. And then lastly, this isn't new to Terraform. This is something that has existed for a while, the ability to manage resources. But within those projects, you can now specify that you want a resource to live inside of a particular project. So here I'm creating a compute instance, and I'm saying this compute instance lives in the project that I just created. So that Terraform demo project I just created, we're dropping this resource in there. And if we had used a count attribute, we would be able to create this resource in every single project that we create, allowing us to build something like a training environment or ephemeral environments for staging, QA, dev, whatever it might be. So the goal here, the vision, is to enable reproducible, isolated, and codified environments, regardless of your cloud provider, your multi-cloud, or your hybrid cloud situation. When we enable the ability to capture infrastructure as code, we get all of the benefits that application developers have had for years, while we get the reproducibility, the multi-cloud, and the hybrid cloud approaches that allow us to be highly scalable and highly agile in today's multi-cloud environments. Thank you.
Thank you, Seth. And this brings us to the end of our talk. Just to summarize, over the last hour, we went through how to use IAM roles and permissions to achieve the principle of least privilege, using resource hierarchy to both have central control and delegate autonomy to our independent teams. Org policies can then allow admin to set guardrails around these flexibilities. And automation is your key for scalability and repeatability. And finally, using open source tools, you can leverage all of these capabilities but customize for your own environments. So this is the slide for your photo needs. It's a summary of all the launches we have mentioned and where to learn more. We have a few minutes left, so we could do some questions. There are 2 microphones in the middle. We're also going to be at the Meet a PM sandbox afterwards, so if you want to come and chat in details, that could work too. OK, thank you.